Assalamualaikum and hello doctor. So we are presenting our SECV 4233 project, volume visualization and flow visualization using VTK. So part 1 covers ISO surfaces and array matching on 5 volume datasets, plus an external one we downloaded. And part 2 covers 4 flow visualization techniques. So I'll pass to Umi to start on ISO surfaces.
Assalamualaikum, my name is Umi, and for my part, I will be doing the ISO surface extraction. We use the VTK contour filter, and our keyboard callback changes the ISO value live. So the arrow keys step by 10, press keys by 15 shown on the screen, the on-screen HUD. And on the head city, ISO values 500 give us the skin surface and 1150 the skull. That's all from me.
Right, thank you, Umi. So I'll be doing the demonstration of this dataset. So when we press up, so it'll be showing the skull and press down, showing the face, and if you page down, it increases the size, and we can reset the camera. So W is the wireframe, and S is the surfaces. So that's all. So all is the same. So right, select dataset, same also.
So I'm gonna presenting the GPU ray marching. The model replacement for VTK is removed for raycast mapper, and the U and I key change the ray step size crosshairs, then renders the faster but blockier and finer step for each sharper. So each dataset has its own color and opacity transferred to the function, and the skin render faint so the step size control the and we added the controls where the O and P keys shift the opacity function, leaf and C keys cycles the per data set, color and M switches the composite and maximum to intensity blending.
I think so I'll be showing demonstration. So press O, in darken. Let's press P, it'll be lighter. Okay, so now let's press C. It's gonna cycle between the colors. Press U, you can see I. Gonna define the finer of the course. Press M and B. So we toggle the bounding box, the camera size, can we set the camera? That's all for Azim. All the same application of all the datasets. It is good. Okay. Team. Stephanie. So I'll be passing on to Fatia.
Okay, so hi, I'm Fatia. I will be presenting the hedgehog technique. So align at every grid point showing the flow vector. Because the assignment notes the default line are far too long, so we tune the scale factor interactively. Too small and the flow is invisible, too large and lines overlap into a mess. So we settle on 1.5 for the scale as default scale for both test data sets 1 and 2 and 0.15 for the chaotic utterly, where we also filter out the 97% of points that are near zero background. So only the real blood flow is drawn. So if you press minus several times, the lines will shrink to nothing. And when you press plus, it will go past the good values and become a solid mess. So we settle back at 1.5 as the default.
So I'll be presenting on glyph visualization. So we replace the headshot lines with cones from VTK cone source connected through VTK glyph 3D. The input connection carries the vector data. The source connection, the cone shapes, scale by vector magnitude exactly as the assignment specifies. So unlike lines, cone shows flow direction unambiguously. So we compare several cone sizes and live with the bracket keys. So small cones preserve detail in dense regions. Larger ones read better from distance. Scale up, press plus, and we scale down, press minus. And to increase or decrease, to decrease, press left bracket. To increase, press right bracket. So from me, we're applying all the same, all data sets. Okay, I'll be moving on to Fatin.
Thank you. My name is Fatina Dersdina and I will be presenting the streamline. So the all VTK streamline class no longer exists in VTK, so we use its module replacement, which is the VTK stream tracer with range kuta for integration. So the streamline are seeded on a regular grid inside the EZ coordinate range from the assignment, and we can also add new streamline interactively by pressing A under the mouse, and it will reveal the vortex. So the carotid dataset needed a smarter approach where 97% of it is empty background, so a regular grid produce no streamline, and instead we sit only where the velocity is real, placing all start points inside the artery itself. So if we hover on interesting vortex and press A 2 or 3 times, a new streamlines will appear under the cursor, and then press T for tubes.
Fatin. So if we want to add seed, we press A. From to clear, we press C. And plus It's going to increase the density. So we minus, decrease. We want to add tubes. And press here. Press T.
Okay, so the next one is the stream glimpse, which is the tornado. So this is the stream point task where the cone sample along each streamline line up tip to base. So we apply it to an external engineering dataset, which is this tornado vector field, where the cones trace the funnel rotation and the red blue coloring shows the two direction of swirl around the core. So slowly rotate tornado with the mouse and press once or twice for more cones.
Right, press plus and increase the cone size. Minus. And so you want to maybe less cones, we press comma. Increase cones, we press plus. And to increase or decrease the cone radius, left bracket to decrease, plus to increase. And L is to remove the line. That's all from us, Doctor. Thank you.